Thank you all for being here this lunchtime. Uh, this is a part of a research project which was born as a collaboration between the health department in Catalonia and well, was about to say Autonomous University, but actually it started when I was at UAB at the Universitat de Barcelona. The idea was the main goal of the project was to tackle how the primary care system could be a reference system for detecting cases of gender-based violence. So those are started. Yeah. So the framework of gender-based violence is well known. It is a very important public health issue, as according to the last estimates by World Health Organization, 1/3 of women worldwide have suffered physical or sexual violence in their lifetime. In Spain, in 2019, there was a survey conducted over 10,000 women that concluded very similar results. According to this survey, 21% of women have suffered physical violence in their lifetime, and almost 14% have suffered sexual violence. So the estimates are well similar to those by the World Health Organization. Besides that, there's an important issue when trying to handle this public health problem, which is that only 32%, according to the same survey, only 32% of the victims report being victims of gender-based violence. So and even less people use the primary care system to get help for this problem. So this is what in the literature has been called the gender-based violence iceberg, because we can only see a very limited part of what is actually happening. So there are many reasons that why this is happening, both personal and societal reasons, right? So the goal of the primary care system was to be able to identify the magnitude, to estimate the magnitude of the number of cases that go unreported, unseen for them, and then doing something about it. So what there have so far these training activities, they were also interested in evaluating how well these training activities were going. These training activities were activities aimed at sensibilizing the professionals responsible for detecting the cases, and in particular in the period of time of the study. In 2019, there was an intervention with this objective among the health professionals who were responsible for detecting the cases within the primary care system. So this is one of the things that we had to take into account when modeling this data. And the other thing was the COVID-19 pandemic, which was also inside the study period. So there's a lot of literature stating that during the COVID-19 pandemic, there was an increase in the cases of due to confinement of population and having to this forced coexistence between victims and aggressors. the cases of gender-based violence were increased in this period. In particular, we consider this period of strict confinement in Spain, which was from March 14 to June 21 in 2020. So there's also a recent study showing that the number of calls to Spain's helpline for gender-based violence also reflects this increase during this period compared to previous years. So there's a lot of evidence that this happened, but as far as we know, there's no estimation of the magnitude of this increase, at least with this approach that we are proposing in this study. Okay, so the objectives of the study, and in particular the modeling framework that we are proposing here, is to evaluate the impact of this 2019 awareness campaign, to evaluate the impact and estimate the impact of the COVID-19 pandemic in the number of cases of gender-based violence, see what's going under the gender-based violence iceberg in the context of the Catalan public primary care system, and estimate the actual evolution of gender-based violence cases in northern metropolitan area of Barcelona, because this is where our data came from. But as I'll discuss later, these results are very straightforward, general visible to any other context. So the data we use are mainly the weekly number of gender-based violence diagnoses in this health area. The northern metropolitan area is very large and is one of the largest. I think it's the largest area in terms of population in Catalonia, and is also one of the more heterogeneous in terms of GDP and socio administrative profiles. So it was interesting to have data from this area. We also had the number of women assigned to each administrative area. So we for computational reasons, we had to separate the number of cases in 6 areas within this northern metropolitan area, which has no meaning for us, but we had to do that for computational reasons. And then we needed to know how many women are assigned to each. So how many, it's like a number of exposed people. And then we had the results of the survey conducted in 2019 by Spanish Ministry of Equity over 10,000 women on gender-based violence. So we used this data from the survey to estimate, to move these results into what we should be expecting in each administrative area of the northern metropolitan area of the primary care system in Catalonia. So this is just the average. So we used the results of the survey just to have like an overall average idea of how many cases should we be expecting per week on each area, depending on the number of exposed women. So the modeling approach is basically considering that we have 2 processes, one that can be seen, and so this the weekly number of gender-based violence cases registered in each place, And then another process, which is this xt, which represents what is actually happening, which cannot be observed, right? So what we assume for each week between the period 2010 to 2021, we assume that the number of cases following a Poisson distribution, which is very common in a discrete context like this, and this mean, so the outside the COVID-19 period, this Poisson distribution has mean lambda, and this mean was increased in beta term in this period from March 14th to June 24th. So this is the mean of the Poisson process for the representing the actual number of cases every week, right? So we can express it like that. Lambda is the non-COVID-19 average, is an indicator of whether we are within the COVID-19 period or not, and beta is the increased factor associated to the COVID-19 pandemic. So besides that, we have another process, which is what we'll see by the primary care system, and you express this process in this way, right? Basically, this circle operator here is the binomial thinning operator, which is a sum of independent Bernoulli random variables, right? So the idea is that for each case that we have, we can register that case with a certain probability or not see that case, right? So this is the idea. And this distinction between Q0 and Qt is because we want to be able to measure the impact of the training activity as well, right? So we expect that the probability of seeing a case before the training is different than the probability of seeing a case after the training. And how those two parameters are related is we consider two ways. We consider that the impact of the training is somehow linear on Q0. So just at the beginning of the period before the training, we had a certain probability of seeing a case that happens. And after the training, this probability is increasing in a linear way, right, on time. We also considered a different shape for this Q0 in assuming an exponential input, right, of the training activity instead of the linear one, and we'll see what makes a lot more sense. Also for practitioners, made a lot more sense in the like that the impact, the training has a deep impact when it's delivered, but somehow its impact is decreasing in time. So it's not increasing linearly. So we saw that modeling, we fitted both approaches to the data, and with information criterion, we can compare how both approaches perform. And we saw that the exponential is working better. So in the linear approach, we can assume that parameter alpha is the moment when there's no underreporting at all. So we can see all the cases, right? So this is the moment where all the cases are registered by the primary care system. Okay, so all the parameters in the model were estimated within a Bayesian framework using Git sampling and using the R2JAX package. Right, using appropriate priors means that we used very uninformative priors in all the cases. So we consider three different scenarios. When the first one is based on the estimates provided by the National Survey in 2019. So we are assuming that 32% of women are victims of gender-based violence, and only 16%. These are the estimates provided by the 2019 survey. So the second scenario, as I said, the idea of the primary care system was to increase the importance of the system in the detection of gender-based violence. So we defined two additional scenarios. One where 32% of women are still victims, according to the 2019 survey, but 50% of the victims go to the primary care system. And the third scenario is the same, but assuming that 90% of the victims will go to primary care system. So this also scenarios 2 and 3 also based on previous research, stating that one indicator of potential gender-based violence is using the primary care system more often than the general population. So this is the Debian's information criterion, which is what we use to compare the two approaches for modeling the impact of the training activity, right? So as in most information criteria, the lowest value is the better. So in all cases, in all 6 superiores of the Northern Metropolitan Health Region, the exponential approach for the impact of the training performs better. So I'm showing the aberration of QT. This is the proportion of seen cases in the linear approach, which is something like that. So until 2019, we have the Q0, and then we have QT growing linearly here, right? But so yeah, and going to 1. So this is the moment where all the cases are swing biases, right? But from now on, all the results I'm showing are based on the exponential assumption, which is the one that performs better. So assuming the exponential shape for the impact of the training, well, we see something like that, right? So after the training, immediately after the training, the impact is very high, but then the impact is moderate. And that should also made more sense for practitioners than the linear approach. So that made sense for us as well. So this is the estimated bit where virtually all the cases will be seen by the public health system according to the first scenario, according to the estimates by the 2019 survey, right? So we can see that in order to be able to see only 16% of the cases in one of the regions, we should be waiting until 2041. And there are some, we can see that all the this distinction between super West was only for computational reasons, and it does not tell us anything actually. But it was interesting that all the superiors are very similar in the percentage of reported cases. It's all based on the first scenario, except for area E, where almost 40% of the cases are C, right? And We don't have an explanation for that. For this difference, because we don't know what these subareas represent actually. This is the impact of the training under the second scenario. So the idea is that the shape is exactly the same, and the shape is very similar to the previous scenario for all the areas. But in order to be able to see 50% of the cases, we have to wait a little bit more, right? So in sub area C, for instance, have to wait until 2106 in order to be able to see virtually all the cases, well, 50% of the cases on the primary care system. So this is very similar to the previous scenario, exactly the same behavior, and very similarly for the third scenario, right? The difference is that in order to be able to see 90% of the cases, we have to wait even more, right? Which makes sense, and is very similar as well. So this the estimates for the Q0. So this is the proportion of cases that we are seeing deferable training, right? So we can see that for all the areas, the proportion of cases is very, very low, right? And lambda is the estimated average for the non-COVID-19 period. So this is the average number of weekly cases that we see outside March to June 2020. This for the second scenario, where we can see that the expected average number of weekly cases is higher, because we are seeing 50% of women instead of 16% as in the first scenario are seeking help by the primary care system, and the proportion of cases is low, and even lower for the third scenario, where 90% of the victims seek help by the primary care system. So the impact of the COVID-19 confinement is the increase in the weekly average number of cases. We see that an increase between 1.8, more or less, right? In all the cases, a significant increase. So we can also see that this model can detect this increase due to the COVID-19 pandemic as well. So for the second scenario, the increase a little bit higher, but within the same range, and the same for the third scenario, right? Which made sense in terms that we don't expect that the impact of COVID depends on the proportion of women seeking help by the primary care system, right? So that makes sense. Okay, so another thing that this modeling approach allows us to do is to reconstruct the evolution of the process, right? So in, let's say, blue or green, we have the registered number of cases each week between 2010 and 2021. This vertical black line represent the moment where the training starts in each subarea, and these two red lines are the COVID-19 period, right? So we can see that there's obviously the reconstruction is higher in red for each subarea. The more similar is subarea E, where the proportion of cases, of registered cases, were also higher, right? And it's very obvious from the registered data that the training had a significant impact, right? So in all superiors, we see that there's an increase in the detection of gender-based violence cases after the good training. So under the second scenario, these two lines are even more far away. And on the third scenario, it's even worse, right? So, well, in terms of model diagnosis, so I'm not going into that, but we see that the behavior of the posterior distribution of our parameters is as we expected. And more interestingly is that if I reconstruct the Y process instead of X, what we get is extremely similar to what we observe, which is a good thing, right? So in order to be sure that the model is estimating what we expect it to, we run an exhaustive simulation study with this structure and with known parameter values, right? So we could see whether the estimates are what we used to run the simulation or not, right? Both for the linear and exponential modeling of the impact of the training, right? And what we'll see is that the behavior of the model is as we expect and significantly better for the exponential shade for the impact of the training, right? In all the cases, we get very limited bias on the estimates, very reasonable average interval length for the 95% credible intervals, and reasonable coverages for these 95% credible intervals. So the model behaves as we expect. Also, in terms of goodness of fit assessment, in some to some extent, we also compared this data to the number of calls in the Catalan line for gender-based violence victims. Now, I will show you the comparison between these two things later on. So the idea is that we've seen that with this modeling approach, we see that only 16% of the cases between 2010 and 2021 in this health area were detected by the system, right? There's a difference if we compare the proportion of detecting a case before the training of the professionals and after the training. So let's say that these kind of actions have an impact in detecting the cases in a proper way, right? So we saw an level reduction in the underreporting issue, be comparing the estimates before and after the training, right? So we also see that an average growth of 1.25 cases per week can be attributed to the COVID-19 mandatory confinement. Unfortunately, these results are probably generalizable to other areas because this northern metropolitan is quite heterogeneous and quite large, right? So this is the graph I was talking about. So in red, we have the weekly number of calls to the Catalan gender-based violence victims term. In blue, we have the number of cases. This is the overall number of cases in the northern metropolitan area. And in green, we have the reconstructed overall number of cases in the northern metropolitan area. But this is the number of calls in the northern metropolitan area as well. We could filter by where these calls were coming from. So what we see is that the model is able to get the other of the process, but the variability is significantly underestimated, right? So that opens also a big door for future research, assuming other distributions for the actual process instead of Gaussian, right? So it makes a lot of sense for us. Okay. Another line of research, very interesting line of research, is also detecting differences between the estimates provided by the 2019 survey and the old. There was a survey before the 2019, I think in 2015, and the primary care data in terms of is the primary care system detecting all, so the underreporting issue on the primary care system is equal for all subpopulation of victims, or are there some subpopulations more likely to be undetected by the system, right? And for instance, what we saw here, we studied the probability of suffering gender-based violence depending on age and depending on the source of data, right? So we have the 2015 Saudi here. We have the 2019 Saudi here with a very similar profile, right? So we see that from 16 level, then the probability is decreasing that values level, and there's a completely different profile for the primary care data, right? In which younger victims are more unlikely to be detected as victims by the primary care system. So that gives us an idea that probably special efforts should be done to detect the cases where the victims are young, right? Because this is where the primary care system is more likely to fail. Y-axis is the estimated probability of suffering violence, generalized violence. Yeah, that's it. 100, I think. Yeah, there's also the range in the surveys and in the primary care data. Yeah, but the interesting thing is that the beginning of, so the youngest ages, we see that the profile is very different, right? So from 16, in fact, in the 2015 and 2019 surveys, it's almost all the time is the probability is decreasing, whereas the primary care group will have an increase at the beginning, so it's more unlikely to detect cases for youngest victims on the primary care system compared to self-reported surveys, right? So that's also interesting. Okay, so that's all, and there's more information about this project on these two websites. I'll be happy to answer your questions.